Hello friends. In this video, we will take a look at two smart home devices at once and compare them with each other. These are presence sensors, but they are not quite ordinary. They do not detect movement like PIR sensors and do not analyze micromovements like radar sensors. A different principle is used here, detecting pressure on a surface. Each device is based on a sensitive strip. In one case, it is a fabric element. In the other, it is a material resembling eco-leather. When a person sits down, lies down, or simply applies pressure to this strip, the sensor detects presence. The operating principle is similar to that of contact or leak sensors, except that instead of a magnet with a reed switch or exposed contacts, a sensor strip is used here. Such sensors are especially useful in places where static presence must be detected reliably. For example, when a person is sitting on a sofa or lying in bed and barely moving. In such scenarios, a pressure sensor may be more accurate than even sensitive microwave radar sensors because it responds not to movement, but to the actual presence of a load on the surface. Next, we will examine and compare the package contents and design of these devices, test their operation in the standard Tuya Smart ecosystem, and then move on to alternative connection options, Home Assistant through ZHA and Zigbee2MQTT. Before we begin, as usual, please like this video so that more people interested in smart home technology can find it, and subscribe to my channel if you have not already done so. Let us start with the package contents. Both sensors arrived in simple white cardboard boxes without any printing. The only identifying marks are labels printed on a thermal printer showing the model, device type, and basic service information. The contents are also quite minimalistic. On the left is the sensor with a fabric-sensitive strip, which I will refer to as the light-colored sensor for simplicity. It came in a more compact box. On the right is the second version, with a wide black strip made of a dense material resembling eco-leather. I will refer to it as the dark-colored sensor. It comes in a larger box, and each device includes a small instruction manual. The specifications of the sensors are similar in many respects. Both operate using ZigBee 3.0 and are designed for use in the Tuya Smart or Smart Life ecosystem. The light-colored sensor with the fabric strip is available in two versions based on the length of the sensitive section. The version I have for this review is 295 mm long, and there is also a longer 635 mm version. This sensor is powered by two AAA batteries, but they are not included. The dark-colored sensor has a noticeably wider strip and is also available in two lengths, 400 and 800 mm. The version in my review is 400 mm long. The power source is different here, a CR2032 battery, which is included. Externally, the light-colored sensor strongly resembles a leak sensor with a remote probe. I have already reviewed a similar device on my channel. Such sensors have an external wire with a sensitive element at the end, which makes them quite convenient to modify for different tasks where contact closure or opening needs to be detected. The principle here is similar, except that instead of two exposed contacts, a pressure-sensitive strip is used. Press it, the contact's close, and the sensor transmits an event. The dark-colored sensor also resembles a leak sensor, but in a puck-shaped form. In such models, the contacts are usually located on the bottom. The sensor comes into contact with water, the contact's close, and the device sends an alarm. In this case, instead of water, a wide sensitive strip is used. When pressure is applied to it, the sensor is triggered according to the same contact closure principle. In other words, the manufacturer did not invent anything fundamentally new, but took a familiar sensor design and simply replaced the signal element with a strip that responds to pressure. The difference between the two sensors is clearly visible here. In the light-colored version, the sensor itself is separate and connected to the sensitive strip by a wire approximately 40 centimeters long. The strip is soft, made of fabric, bends easily, and conforms to the shape of the surface. Its length is 295 millimeters, and its width is about 5 centimeters. The dark-colored sensor is mounted directly on the strip, and the entire assembly looks like a single device. The short version is 40 centimeters long, so it is noticeably longer than the light-colored one and almost twice as wide, about 9 centimeters. The material is also different. It is dense, has a texture resembling artificial leather, and is significantly stiffer. Now let us look at the power supply. The light-colored sensor operates on two standard AAA batteries. In my opinion, this is an advantage. Such batteries are easy to find, inexpensive, and their capacity should be sufficient for a ZigBee sensor of this type for a long time. Moreover, the sensor spends most of its time in standby mode and only transmits a change in state. The sensor reset button is also located under the battery compartment cover. The dark-colored sensor has a different power supply design. Structurally, it almost completely duplicates puck-shaped leak sensors, a round housing, a reset button on top, and a battery compartment on the underside. The battery compartment cover is unscrewed using a coin. This design is usually used to provide sealing. A CR2032 battery is installed inside, and it is already included. During shipping, it is separated by a dielectric tab to prevent it from discharging in advance. Before the first use, this tab simply needs to be removed. Now let us move on to connection and, as usual, first test the standard control system, Tuya Smart. Since both sensors operate via ZigBee, they require a compatible ZigBee gateway. Open the gateway, go to the section for adding new devices, and start the search. To put the light-colored sensor into pairing mode, open the battery compartment and hold down the small black button until the red LED on the front of the housing begins to flash. With the dark-colored sensor, everything is simpler. Hold down the large push button on top until the green indicator beneath it begins to flash. After that, the gateway finds both devices, and they are added without any problems. They are identified correctly in the application, and Tuya even loads actual images of these sensors rather than just a generic icon. The light-colored sensor is displayed as a pressure-sensitive strap, while the dark-colored one is displayed as a pressure sensor. Both devices appear in the gateway's list of child devices and are ready for further configuration. After adding them, there is another reference to leak sensors. Tuya treats these devices as alarm sensors, so it immediately suggests checking notifications. The setup wizard recommends enabling application auto start and allowing it to run in the background so that trigger notifications are delivered even when Tuya Smart is not open on the screen. After this check is completed, the sensors appear in the general device list. The light-colored sensor opens in a plugin with a blue background. It displays the battery level, the current pressure status, and two timing settings. How many seconds after the load disappears the sensor switches to the no pressure state, and how many seconds after the load appears it switches to the pressure detected state. The dark-colored sensor looks simpler. Its plugin has a green background and displays the current status and event log. When pressure is applied to a sensor, this is immediately visible in the general device list. The time of the latest event appears next to it. When triggered, Tuya displays an alarm notification, almost the same way it does with leak, gas, or smoke sensors. After the pressure is removed, a reverse event is received, the normal state. In other words, in the standard ecosystem, both sensors operate as alarm sensors by default. Now let us look at the settings. The light-colored sensor has quite a few of them. The first setting is the delay before switching to the no presence state after the load has physically disappeared from the strip. The default value is 5 seconds. The second works in the opposite direction. It sets the delay from the moment pressure appears until the sensor is triggered. The default value here is 0 seconds, meaning the response should be immediate. Next is the pressure sensitivity setting. 3 levels are available: low, medium, and high. There is also a notification section. Push notifications in the application are free, while SMS messages and phone calls are offered as additional paid options. Trigger notifications can also be disabled separately. In that case, the sensor will continue changing its status, but alarm messages will no longer be sent. The dark-colored sensor has noticeably simpler settings. It displays the battery level and has 3 notification switches: low battery, pressure detected, and return to normal state. It is better to leave the low battery notification enabled, while pressure events can be disabled if desired. In this mode, the sensor will function simply as a state sensor without constant alarm push notifications. The general settings of both sensors are almost identical. Here you can view device information, go to automations, share access, create a group, enable offline notifications, check for firmware updates, or remove the device from the system. In my case, both sensors arrived with up-to-date firmware, and no updates were available for them. Now let us carry out a small test, starting with the light-colored sensor. We will test it at all 3 sensitivity levels: low, medium, and high. I will start with the high level to see how easily the strip responds to a light load and whether objects placed on top of it cause false triggers. For the first test, I covered the sensitive strip with a large sofa cushion. This simulates a situation in which the sensor is placed under a blanket, sheet, or some other soft layer. As you can see, even at high sensitivity, the cushion alone was not enough. The sensor did not detect presence. However, when an additional load is placed on top, the sensor triggers immediately. For the test, I used a 2.5 kilogram weight plate. After that, the status in the application changes to pressure detected, meaning the sensor detects a noticeable load rather than just a light touch or the weight of fabric placed on top. Now let us switch to the medium sensitivity level. Here, the sensor becomes noticeably less sensitive. Even 2 weight plates, or approximately 5 kilograms of load applied through the cushion, are not detected. The status in the application remains unchanged, no pressure. However, when the load is increased to 3 plates, the sensor triggers. In other words, at the medium level, it requires more substantial pressure and already ignores light accidental loads. This may be useful when installing it under a cushion or soft upholstery to prevent false triggers. At low sensitivity, the threshold becomes even higher. The sensor ignores 3 plates, and it only triggers at a load of approximately 10 kilograms, or 4 plates. As a result, the light-colored sensor clearly demonstrates that the sensitivity adjustment actually works and noticeably changes the trigger threshold. Now let us carry out the same test with the dark-colored sensor. The initial conditions are the same. The sensor is placed under a sofa cushion, and we will gradually add load on top. It does not respond to the cushion itself, so it can be safely hidden under a soft surface. The covering alone should not cause accidental triggers. Next, we increase the load. However, unlike the light-colored sensor, the dark-colored one does not trigger with 1, 2, 3, or even 4 plates. In other words, even approximately 10 kilograms applied through the cushion was not enough for it. Moreover, the sensor still did not trigger with 8 plates, which is already about 20 kilograms. The plates were stacked in a single column and pressed directly on the sensitive strip area. On the one hand, this provides good protection against false triggers, but on the other hand, the sensitivity of this version is clearly much lower. It only triggered when I additionally pressed down on the plates with my hand, meaning the actual load was already greater than 20 kilograms. And of course, it triggered when I sat on the cushion directly over the strip. In this scenario, the load on the sensor was approximately 80 kilograms, and the application immediately displayed the pressure detected status. Now let us check the automation section, starting with the light-colored sensor. Quite a few parameters are available here as conditions or triggers: pressure status, battery level, sensitivity, illuminance value, time intervals, presence duration, absence duration, and operating state. The main parameter is pressure status, pressure detected or no pressure. Battery conditions can be set to greater than, less than, equal to, or within a range. The sensitivity level can also be selected in automations: low, medium, or high. For some reason, an illuminance parameter is also available here, even though no illuminance sensor is specified for this device. Most likely, this is simply a leftover from generic firmware or a device template rather than an actual function of this sensor. Next are the timing conditions. You can use delays for the appearance and disappearance of presence, as well as a separate operating state parameter. Pressure detected, no pressure, pressure maintained for 5 or 30 minutes, or, conversely, pressure absent for 5 or 30 minutes. The dark-colored sensor is noticeably simpler. Only pressure status and battery level are available as triggers. For the status, you can select pressure detected, normal state, or the duration of either of these states. Automation actions are available only for the light-colored sensor. Sensitivity can be changed from a scenario, and the intervals for pressure appearance or disappearance can be configured. Now let us move on to testing in Home Assistant. At the time of testing, the current version of Home Assistant OS with Core July 1st, 2026 is being used. As usual, we will start with the standard integration for ZigBee devices, ZHA. I am using a Home Assistant Connect ZBT. One is the coordinator, formerly known as SkyConnect. We start adding a new device through ZHA and put both sensors into pairing mode. Both sensors are found and added to the system. The dark-colored sensor is shown on the left, and already during the addition process, several entities can be seen. On the right is the light-colored sensor. It also connected, but an issue is immediately noticeable. Apart from the service entity for firmware updates, ZHA did not create any useful entities for it. We will look at this in more detail next. A detailed check confirmed that the light-colored sensor is not properly supported in ZHA. The device is added to the network, and its TS0601 model and manufacturer are visible, but there are no useful entities for working with pressure. Essentially, Home Assistant sees the ZigBee device itself, but does not understand which data it should receive from it or how to interpret that data. To be safe, I tried reconfiguring the device. Sometimes this helps if the sensor did not complete the initial interview correctly. However, in this case, reconfiguration, as well as reconnecting the device, did not change the situation. Therefore, a separate Quarks file is required for this sensor to work through ZHA, and it is not currently supported out of the box. The dark-colored sensor, on the other hand, was detected correctly in ZHA. In addition to the standard firmware entity, two sensor entities appeared. The main one is responsible for the state of the strip. When pressure is present, it changes its status, and this can already be used in Home Assistant automations. Another sensor was also added, which most likely comes from the device's generic firmware and has no practical use here. The response to pressure works correctly, but the logic is displayed not as pressure detected or no pressure, but as a regular contact sensor. When a load appears, the sensor switches to the open state. In other words, ZHA treats it approximately like a door or window contact sensor being triggered, although in reality it represents pressure being detected on the strip. When the load is removed, the sensor returns to the closed state. The history shows that the transition is not immediate. In my test, approximately 10 seconds passed between removing the load and returning to the normal state. Overall, this is acceptable for present scenarios, but this small delay should be taken into account when configuring automations. Now let us move on to testing through Zigbee2MQTT. At the time of testing, version 2.12.1 is being used. A network ZigBee gateway based on the CC2652P is connected as the coordinator, and its firmware is quite old, from December 2022. This makes it even more interesting to see how both sensors perform with it. We enable pairing mode, put the sensors into connection mode using their buttons, and both devices are added without any problems. In Zigbee2MQTT, they were detected immediately out of the box, correctly identified by model, and even loaded actual images. At this stage, support clearly looks much better than in ZHA. This is what the information page for the light-colored sensor looks like in Zigbee2MQTT. The device is identified as natively supported, and the interview was completed successfully. Its type is an end device, which is expected for a battery-powered sensor. Its network address, ZigBee model TS0601, manufacturer, and the device definition used in Zigbee2MQTT are displayed here. In other words, unlike in ZHA, the sensor is correctly recognized here and is ready for further examination of its entities and settings. And this is the information page for the dark-colored sensor. The situation is similar here. The device is natively supported, the interview completed successfully, and the type is also end device, meaning a battery-powered end device. In Zigbee2MQTT, it is identified as model TS0203. The actual image of the sensor, battery level, device addresses, manufacturer, and MQTT topic are displayed. In other words, both sensors are recognized correctly in Zigbee2MQTT without custom converters or additional configuration. Now let us open the Exposes tab for the light-colored sensor. A complete set of entities is visible here: presence detection, which is effectively pressure on the strip, battery level, and sensitivity adjustment, low, medium, and high. Illuminance is also displayed separately, even though the device does not have a light sensor. Most likely, this is simply an extra entity left over from a generic device template or firmware. I will return to this point a little later. Below are the timing interval settings. You can set the delay before switching to the no presence state after the load is removed, as well as the trigger delay when pressure appears. At the very bottom, the current operating state of the sensor and the ZigBee signal quality are displayed. There is one important detail. To change the sensitivity, simply selecting the required level in the interface is not enough. First, you need to press the button inside the sensor's battery compartment and then immediately send the new value from ZigBee2MQTT. This is how the light-colored sensor triggering is displayed in ZigBee2MQTT. When pressure appears, the occupancy entity changes to occupied, meaning presence has been detected. At the same time, the illuminance value also changes. Here it shows 600 lux. However, it is important to understand that the sensor was not physically moved, the lighting in the room did not change, and there is no actual light sensor in this device. After the load is removed, the configured delay passes, 5 seconds in my case, and the sensor returns to the clear state, meaning presence is no longer detected. At the same time, the illuminance value changes again, even though no real changes in the conditions occurred. Now let us look at the Exposes tab for the dark-colored sensor. The set of entities is much simpler here. Pressure status, low battery status, battery percentage, battery voltage, and ZigBee signal quality. In the normal state, the pressure parameter shows false, meaning there is currently no pressure on the strip. When a load appears, the pressure status changes to true. In other words, in ZigBee2MQTT, this sensor works in the simplest possible way, without extra modes or additional settings. Only a binary state, pressure detected or no pressure. Let us summarize. Both sensors perform the same task, detecting presence based on pressure applied to a surface, but their characteristics are quite different. The light-colored sensor seems more versatile to me. It has a soft fabric strip, a separate electronics unit connected by a wire, power from ordinary AAA batteries, and most importantly, adjustable sensitivity. There are disadvantages as well. It did not work properly out of the box in ZHA, and ZigBee2MQTT exposes an unnecessary illuminance entity that the sensor does not actually have. The dark-colored sensor is simpler. It has a neater monolithic design, a wide dense strip, a CR2032 battery already included, and it worked properly not only in Tuya Smart and ZigBee2MQTT, but also in ZHA. This is an advantage, especially if you use Home Assistant's standard ZigBee integration. However, its sensitivity turned out to be noticeably lower. It did not respond to the cushion or even to a substantial load, and it only triggered reliably under genuinely high pressure. Therefore, it is suitable for an armchair, sofa, or an adult person's bed, but it may be too stiff for lighter scenarios. If choosing objectively, the light-colored sensor is more interesting for flexible configuration and experimentation. It is easier to adapt to different tasks, has higher sensitivity, and offers more options in Tuya and ZigBee2MQTT. The dark-colored sensor is better suited to users who need a simpler and more rigid design, fewer false triggers, and support in ZHA without additional modifications. Therefore, there is no universal winner here. For precise presence detection with an adjustable threshold, I would choose the light-colored sensor. For a scenario where someone has definitely sat down or lain down, and when using ZHA, the dark-colored one looks more practical. That is all. I hope the video was useful and interesting to you. I would appreciate your likes, as they help promote the video on YouTube. If you do not want to miss new reviews and tutorials, subscribe to my channel. In the description below the video, you will find all the necessary links to the devices, as well as to my social media accounts, Telegram channels, and the group for discussing smart home topics. Thank you for watching. See you next time, and peace to everyone.